Welcome to GPS 101, a SAR 34 training session on the proper use of GPS technology and the methods to achieve success in the field. Whether you're brand new to search and rescue or just need a refresher, this session covers what GPS is, how it works, and how we use it on task. So, what is GPS? GPS stands for Global Positioning System. It's one type of what's more broadly called a Global Navigation Satellite System, or GNSS. At its core, it's a satellite based radio navigation system, a way to determine your position based on your relationship to satellites orbiting the Earth. Your receiver listens for signals from multiple satellites and uses them to calculate exactly where you are. GPS isn't just floating out there on its own, it's actively maintained. Today, that's the U.S. Space Force's 2nd Space Operations Squadron, which has actually been redesignated as the 2nd Navigation Warfare Squadron, along with the Air Force Reserve's 19th Space Operations Squadron. They operate out of Shriver Space Force Base in Colorado, running a global network of monitoring stations and ground antennas that keep the constellation accurate. The system itself is made up of 32 satellites, and that number changes from time to time as they maintain them and take things offline and put new satellites up. There's also 16 ground stations with satellites orbiting more than 12,000 miles above the Earth. And GPS isn't the only game in town. Other countries operate their own systems too, like Russia's GLONASS and the EU's Galileo. Together, these are often just called GNSS, and modern GPS units can pull signals from more than one of them at once for better accuracy. So, how does this actually work? Your GPS receiver measures its distance from multiple satellites at once. You need at least four to get a reliable 3D fix. The space component is the satellites themselves. The control component is the ground stations keeping everything synced and accurate. And there's the user component. That's you as holding the receiver. It combines all that into one single position to tell you where you are at any given time. Now, how do we use this? In a search and rescue context, GPS does a few critical jobs for us. This is verify where we think we are and confirm that our assigned sector has actually been cleared. Helps us spot any gaps or holes in our search area coverage, and also lets us document where we've physically been during a task. We can mark the exact location of any clues we find along the way. So, here's what that looks like on an actual topographic map. Search tracks laid over the terrain here, showing exactly which areas we covered and where the remaining gaps are. And this is the kind of coverage picture GPS data makes possible. So you can see here, and sometimes went pretty far out of the sector assigned area, and there's pretty large areas that are just completely missed at all. Now, the key important things here and how we tie everything together between our paper maps, our handheld maps, and how we communicate where we are with each other ties into two things, and that is a datum and coordinate system. So you might ask, what is a datum? Now, before your coordinates mean anything, you need a datum. So a datum is an anchor point that everything else is measured from. In North America, that's historically been NAD, the North American datum, which originates at Meads Ranch in Kansas and is built from a network of roughly 250,000 survey stations. You can see an example of one such here. Now, for GPS specifically, we use WGS, the World Geodetic System, which was built to account for the Earth's actual elliptical shape. The good news is that NAD 83 and WGS 84 are nearly identical, and that's the datum standard that we use for search and rescue work. The key takeaway is always make sure your datum setting matches across every map and device that you're using. You can see here with these contours some of those slight variances on what the coordinate system would be between NAD and WGS. It's a little more irregular. A coordinate system is a numerical system that you use to describe a position on Earth. That could be easting and northing, latitude and longitude. For our purposes in search and rescue, we use USNG, the U.S. National Grid. It divides the country into grid zones. There's 50 of them across the U.S. 4 cover Maryland, and then it further breaks things down into 100,000 meter squares. A 10-digit coordinate system gets you precision down to 1 meter, and the 8-digit coordinate typically goes down to 10 meters, which is plenty for search and rescue work. Now, here's what that grid actually breaks down. From the UTM zone designation, which obviously universal transmarcator is the other coordinate system, and how it relates to the U.S. national grid's lettered 100,000 meter squares. So you can see all the way down the coordinate like this one shown, and you can communicate exactly where your position is in seconds. So this is UTM here on your left, and you can see it breaks things down numerically here, east and west, and alphabetically here, north and south. From this, so USNG also still keeps the same system, so we still use 18 yes, whether we're in UTM or USNG. The difference is that UTM doesn't break things down further, so you end up with these very large 10-digit numbers across, right? Whereas USNG simplifies things, and it breaks down the 18S grid into even more squares here beyond this, and it gives them a lettering number. UJ is one of the main ones that we have here in Maryland, and that replaces these first two numbers that you often see in the UTM maps. So keep that in mind the next time you look at the margins of a printed map. It might say UTM or USNG, and that's going to help inform you how you're going to read that map. All right, so finally, a quick note here on hardware. The units you'll most likely be issued today and what we see are the Garmin GPS Map 67. There's also the 67i with some more bells and whistles. There's the Garmin 200 and now the Garmin 300, and I'm sure there'll be more newer ones out there by the time this video comes out. The GPS Map 67 series is a rugged handheld with multi-band GNSS support, so it can do GLONASS, it can do GPS, it might be able to do Galileo. So it pulls all those different for all those different GNSS systems together for a little better accuracy, typically in canyons and heavy tree cover. The Garmin also allows you to connect to inReach if you want to do satellite communications and all that stuff. The 200 is great because the Alpha 200 great because that's what you use to connect with the canine collars. The 300s have even more bells and whistles similar to the 67 there. So largely the Astro has been completely replaced, but generally things work the same. There's other videos that I have that will walk through how to set these each and every unit up. So encourage you to go on and take a look. And in the wrapping up here, that pretty much covers everything with GPS, how it works, and what we need it for in the field. So, all right, take care and like and subscribe.